to look at factoring a quadratic where the a term is not 1. So to refresh, if we were to factor a quadratic where the a term is 1, so t squared minus 4t minus 12, that 1 is implied. We take the product of the a term, 1, multiplied by the c term, which is negative 12. So we're finding the product. 1 times negative 12 is negative 12. Then we need to find factors of negative 12 that will multiply together to give us negative 4. So we found that 2 plus negative 6 gives us negative 4, which is our middle term. And indeed, 2 times negative 6 is negative 12. Because this is just t squared, the 1 is there, we can form our binomials. Let's bring our t and t, and then our two factors, 2 and negative 6. So watch the video on factoring quadratics with an a term of 1 if you need some help with this. So following the same methods, if we don't have 1, we're going to take our a term, multiply it by our c term, and we find that we have a product of 20. We want to find factors of 20 that add together to give us negative 21. So what we notice here is this is a negative sign. With this is negative and then the c term is positive, means we're going to have two negative terms. So negative 5 plus negative 4, this gives us negative 9. That's not going to work. Negative 2 times negative 10 gives us negative 20. That's not going to work. Negative 1 plus negative 20, oh, we have negative 21. Perfect. So similar how we just brought our t down to start this, we're going to start with our coefficient of the a term and the variable. So we have 5p in both places. Then we're going to look at our factors, which were negative 1 and negative 20. If we look at these aren't completely factored. We have 5p minus 1 and 5p minus 20. We've got a common factor here of 5. So the first term remains the same. The second term we factor out the 5 and we have p minus 4. If we go in to check this, 5p times p is 5p squared. 5p times negative 4 minus 20 minus this 1p plus 4. So it's the same method. The only step that we have to take here is to remove any common factors in our terms.